Alright, so this video is meant to go over page 7 in the proportions packet. And I know I mentioned that we might do this when I get back, but we'll go ahead and do this now. All we're doing for these 4 questions is coming up with an equivalent ratio. If we have a rectangle, for example, that's drawn with a length of 8 and a width of 28, it's something like that. Now, the goal of this 4 questions is to basically create a similar figure. Now, for example, I could reduce that shape by a half, and then I'd have a 4 by 14, which means you have a 4 over 14. That could also reduce to a 2 over 7, which means some of you might want to have a 2 by 7 shape. It doesn't matter to me what your equivalent ratio is. You can reduce or enlarge each figure, but go ahead real quick and for 2, 3, and 4, just write a fraction that equals the 12 over 30, the 10 over 24, and the 21 over 36. After you write the fraction that's equal, write the scale factor that you used. So for number 1, if I go with the red one, that means up here I'm going to put that my scale factor is a half. Let's say for number 2, you double it and get a 24 over 60. That means you're just going to tell me that the scale factor is 2. So go ahead real quick if you need to pause the video and just answer real quick for 3 and 4. And I assume your answers are going to be okay. Now that you've created a couple of examples of things that are proportional, let's go through how to tell if 2 things are in fact proportional. Moving back up real quick, I'll point out that if we take, for example, the first one, if we cross multiply both of those values, when you multiply 14 times 8, it's the same thing as 28 times 4. Here's another example off to the side. If I want to check to see if 1/2 and 3/6 are proportional, that's a 6, and that's a 6. All right? So down here, we have a rectangle, and the rectangle's dimensions are going to be a 2 by 5. And now we're going to enlarge it by a scale factor of 3. That means this is now going to be a 6, and this is now a 15. Now, 2/5 and 6/15 are proportional. Once again, that's a 30. That's a 30. So you know that these 2 shapes are proportional. Now, what about if I asked about 2/5 and 8/15? So 2/5, is it equal to 8/15? No, not at all. That's a 40. That's a 30. So no, they're not proportional. Now let's take a look at the last one. The 2/5 and the 12 out of the 30. Are they proportional? Yes. Now let's prove it. Here's a 60 and here's a 60. So the first thing we can say is that because when I cross multiply, 60 equals 60. So you know that they're proportional. Now another thing we could have done, and I'll erase this now, if we have the 2/5 and the 12 out of the 30, we're just trying to prove if they're equal or not. So what you could do is you could just reduce the 12 out of the 30. Both of these are divisible by 3. This will give you a 4/10. You can reduce that even further, and that's a 2/5. So if you reduce one of the fractions and it equals the other, then you know that they're proportional. So you can reduce, check if equal. All right? That's the second thing we could have done. Now, what we also could have done is kind of like unreducing. We could have multiplied both of these and gotten a bigger fraction. So you could kind of unreduce, if you want, And then again, check to see if they're equal. And the last thing that I'm going to point out that you could do is you could simply divide to make them both decimals, and then check to see if the decimals are equal. So in the calculator, when you divide 2 by 5, it's a 0.4. And in the calculator, when you divide 12 by 30, it's a 0.4. And they are, in fact, equal. So that takes care of page 7. Thank you.